Hi, I'm Viraj and this is my YouTube channel Maths by Viraj. This is the second video I'm uploading under indices, in which if you forgot or if you missed to see my first video, you can go to the link over here and get to see it. In the first video, I taught you all how to multiply indices, divide indices and raise a power to a power. Today, in this video, I will be teaching you all another 3 rules of indices. Namely, any number to the power 0 is 1, fractional indices and negative indices. Any number to the power 0 is 1. How? Let's try to understand this. Now, using the basic knowledge that we learned from indices from the previous video, we know that x to the power 3, if divided by another x to the power 3, since the bases are the same, we subtract the powers, which gives us the answer x to the power 0. Now I am saying that any number to the power 0 is 1. Let's try to understand it. If I did the working in a little bit of a different way, it would look like x to the power 3 divided by x to the power 3 in such a way. Here, x is multiplied by itself for 3 times and again divided with such a set of x's. Now what I can do is, I can cut the x's or simplify the x's which are on the numerator as well as in the denominator, which gives me the answer of 1 over 1, which is having a numerical value of 1. Therefore, I can say that x to the power 0 is 1. That is, any number or a variable to the power 0 is 1. Now let's consider using numbers. 2 to the power 4 divided by 2 to the power 4. In this, the numerical value of 2 to the power 4 is 2 into 2 into 2 into 2, which is 2 times 2 4, 4 times 2 8, 8 times 2 16. Therefore, I can easily write this as again 16 divided by 16, which happens to be 1. But if we were to write this in terms of indices, this would look like 2 to the power 4 divided by 2 to the power 4 as 2 to the power 4 minus 4. Remember, the bases are same and during division we subtract the powers, which gives us the answer of 2 to the power 0. And again, what is my final answer? 1. So again, I have proved this even without using indices. Just by using numbers, we can come to the answer of 1. Similarly, using indices, I can say that if it is 2 to the power 0, based on this calculation, that 2 to the power 0 is equal to 1. As you can see on the board, children, these are some examples where we can teach you all that any number or any variable to the power 0 is 1. If you have a scientific calculator, you can type this in the scientific calculator and you can see that the answer is 1. So all that you have to remember is any number or any variable to the power 0, the answer is 1. Negative indices. How can an index or a power become negative? And these negative indices are formed only during division. Let's try to see it. Now, usually if it is x to the power minus 2, we write it as 1 over x to the power 2. There's a good proof behind this. For instance, if I wanted to divide x to the power 2 by x to the power 4, Again, based on the rules, if the bases are same and during division, we subtract the powers. So, x to the power 2 minus 4. Now let's look at this. 2 minus 4. 2 minus 4. Here the answer is minus 2. So now we are with a negative power. X to the power minus 2. But how did x to the power minus 2 end up being 1 over x square? Children, I can do this as a fraction. X to the power 2 divided by x to the power 4, which is x into x divided by x into x into x into x. If I simplify this, what I am left with is 1 over x into x, that is 1 over x square. Now if we were to do the calculation based only on indices, we would get an answer of x to the power minus 2. But if we were to carry out the sum in the form of a fraction, we would get 1 over x squared. Right, children? Let's look at another example where numbers or integers are involved. For instance, 2 to the power 2 divided by 2 to the power 3. Here it is division, bases are same, which I can write as 2 to the power 2 minus 3, which is 2 to the power minus 1. Where I can again write this as 1 over 2 to the power 1 or 1 over 2. Both are the same. What if I were to do this in normal mathematical way? 2 to the power 2 is 2 into 2 divided by 2 to the power 3, 2 into 2 into 2. Where 4 is divided by 8. If I divide 4 by 8 as a fraction, it would look like 4 over 8. 4 times 1, 4 times 2. Again, I end up with the answer 1 over 2. Similarly, here 2 to the power 2 divided by 2 to the power 3, the answer is 2 to the power 2 minus 3, 2 to the power minus 1, and I wrote it as 1 over 2 or half. Again, if I did it in the form of integers, I end up getting the same answer. Therefore, children, what you have to again remember is any number, if it is to the power of a negative number, you can write it as a fraction where the index of the power becomes positive and all of this becomes the denominator. Children, I have taken two sums where they have both the same indices and the same bases, but in one I have multiplication and in the other I have division. Now let's try to find whether there's any similarity or whether there's differences between the two sums. Let's try to figure this out in terms of indices. 2 to the power 2 multiplied by 2 to the power minus 3. The bases are same, therefore we add the powers. Plus and minus together, we write it as 2 to the power 2 minus 3, 2 to the power minus 1. 2 to the power minus 1, the answer is half. Very simple. Multiplication of two indices where the bases are the same. We add the powers. Answer we get is 2 to the power minus 1. Ended up having the answer as a fraction half. On the other hand, it is division. When the bases are same and when it is division, we subtract the powers. 2 to the power 2 minus 3. minus and minus multiplied together, it's plus. Where we get the answer as 2 to the power 5, or the numerical value to be 32. Now this is an explanation involved only indices. Let's try to solve this in a more mathematical or in a way where indices are not used. 2 to the power 2 multiplied by 2 to the power minus 3. We know that 2 to the power minus 3 is written as 1 over 2 to the power 3. Therefore, 2 to the power 2 multiplied by 1 over 2 to the power 3. Here, I carry this as 2 to the power 2 over 1. When I multiply them, 2 to the power 2 over 2 to the power 3, which is 2 into 2 over 2 into 2 into 2. Cancel off each other, where I get the answer as 1 over 2. Same as that of what we got in indices. Similarly, for this particular sum, let's try to see 2 to the power 2 divided by 2 to the power minus 3, which is 2 to the power 2 divided by 1 over 2 to the power 3. We know that fractions cannot be divided. Therefore, division changes to multiplication and we get the reciprocal. 2 to the power 2 over 1 into 2 to the power 3 over 1, where two indices are multiplied where the bases are same, which gives me the answer of 2 to the power 5 over 1. Why? The bases are same, we add the powers, therefore it's 2 to the power 5 over 1, getting us the answer of 32. Fractional indices. This is again a very easy part in indices. This is said to be square root of x, or else x to the power half. Similarly, this is said to be cube root of x, or x to the power 1/3. And if a numeral as 5 was to be here, it will be written as x to the power 1 over 5. Therefore, if that's a square root and if there's a number in front, you can write it as the number as the denominator. Let's try to do some examples so it will be easy for us to learn. Square root of 4. Children, this is like 4 to the power half. We know that 4 can be written as 2 into 2, which is 2 to the power 2. So instead of 4, I can now write square root of 2 to the power 2, which means 2 to the power 2 whole into the power half. Now this is like raising a power to a power. Therefore, when there are two powers, we multiply them. 2 to the power 2 into half, which is 2 to the power 1, and the answer is 2. So all what you have to remember is square root sign is that particular number to the power half. Cube root sign, that particular number to the power 1/3. This is applicable for both numbers and variables. Very easy. All you have to know is just try to make sure that you get the perfect denominator from the number that is in front. Let's look at some examples. Here it's cube root of 1000, which is 1000 to the power 1/3. We know that 1000 can be written as 10 to the power 3. Therefore, 10 to the power 3 whole into the power 1/3. When there's a power to a power, we multiply the two powers. where the answer is 10 to the power 1 or 10. Now children, let's try to see what we are going to get over here. Very easy. Now 16 can be written as 4 to the power 2 or 2 to the power 4. Let's try to figure it out in both the ways. 4 to the power 2 whole to the power 1/4. 2 to the power 4 whole to the power 1/4. Now let's look at this. This is 4 to the power 2 into 1/4, which is 4 to the power half. What is 4 to the power half? 4 to the power half is like square root of 4. Again the answer is 2. Similarly, 2 to the power 4 into 1/4, they cancel off easily, giving us a final answer as 2. So whatever the method you use, you will end up with the same answer. 3125 is 5 to the power 5. Therefore, 5 to the power 5 whole into the power 1/5 will give you 5 to the power 5 into 1/5, which is 5 to the power 1, which is 5. Hope you understood today's lesson, and as usual, if there's anything more to be taught or any clarification to be done in teaching, please make a comment below. And stay tuned for more videos and subscribe. Maths by Viraj.